So the other day I explained how to use Meyvn in order to track a Java or Kotlin code base underneath. So the reason this can be useful is because you might be at work where you work on a Java code base or a Kotlin code base. If you want to understand that code base and you are Clojurian, you would like a REPL to do that, then you can hook up your Clojure environment to that Java code base. So you can change the Java source files and immediately in the REPL via Java interop test your changes, and you don't need to recompile the whole project. I did that at work for we were working on the code base was a compiler written in Java and Kotlin. I had to modify the type checker, and I've done it on the REPL. So it's a real thing. Now here I want to show you, for example, I have a Java implementation of BrickSort, OddEvenSort. Here is the Wikipedia page. We're not concerned now with particulars of this sorting algorithm, but just the idea that you might have a work on a sorting algorithm, and you want to have the magic of the REPL. So how does that work? Well, I'm going to import the Java file. And now I have the file available. There is a static method called OddEvenSort. I need an array of ints. As you can see here, OddEvenSort accepts an array of ints. So I'm going to use something like that. Oh, if you want to see the effect of this, because this is Java, this is stateful and very different than the immutable nature of Clojure. We save the array of ints in a var called foo. So foo is this unsorted array of ints, and if I want to sort it, then I do like this, and now foo is sorted. Just as an example, if I do a modification on the file, you can see that the REPL environment will recompile instantly and reload the class. It does static analysis to do the reloading. So if this file had dependencies, it would do the correct thing and reload also the dependencies in the correct order, or the dependents. Now, suppose you have another file. Suppose you have a Kotlin file, which this Kotlin file does the same thing, but I just want to show you that it works also for Kotlin. So I'm going to take this raw file. I'm going to go to the correct directory. So here I'm going to download this file here now. So here I have the Kotlin source file that defines a function OddEvenSort outside of a class. So how would I call this? In the Java file OddEvenSort, we have a class and a static method. Here, the static method OddEvenSort, and we know how to call this, right? We import the class and then we call the static method. But in the Kotlin version, we don't have a class, only a function. So how do we call this? We're going to solve this mystery by looking at what happens in the target directory, where we will find the compilation artifacts from the source file. So if I go to org, then it is at BrickSort. Here it is. I can see that in the absence of a class, what the Kotlin compiler did was take the file name and created a class, because this is the JVM, and Kotlin also needs to be interoperable with the JVM. So it does create a class, which is precisely what Clojure does as well with functions. When you define functions, they are getting compiled to classes. So now I can refer to the class via the package. And the name. And now I can call the function OddEvenSort. And now, as before, we're going to create an array of integers, unsorted. But we have an error because the array cannot be cast to comparable. And if I look at the signature of the function, you can see in the signature that the type of the array that it receives as argument needs to extend the comparable interface. In order to show this in the REPL, instead of creating an array of integers, I create an array that implements comparable, which the Clojure vectors already do, so there is nothing else to do. And now there is no problem. Of course, in order to, again, the Kotlin is also not as immutable as Clojure, so I will do the same as before. Create a var called foo that will reference the array, and then I call BrickSort OddEvenSort on the var, and then the var is sorted. So this is a little bit like how you would work with Kotlin. You can, if you're at work and you work on a Kotlin code base, you can do modifications, and they will be compiled. As you can see, I have the logging enabled for the tracking of the code, the source directories. Every time I do a modification, I will get I will see that in my logs. You can turn this off, of course, if you prefer to work silently. But here I can see that Kotlin compilation result is true. Last thing, maybe, if we want to create a class, then we would need to, I can call this class BrickSort. So if you want to make a static declaration, we need to define a companion object, and we need to annotate this with JVM static. So here we have a problem, compilation result false. This annotation is not applicable to target companion object, and indeed the annotation needs to be on the function. Let me clean that up also. Okay, now it's better. And now the compilation has succeeded. Let's see what happened in the target directory. And now we can see it has created a bit more classes. Now I can import the BrickSort class, which I defined explicitly instead of the BrickSort KT, which was generated by the Kotlin compiler automatically because there was no enclosing class. So here I import the one that I did, and then I can call here OddEvenSort on foo basically, but foo was already sorted. So let's define an unsorted array of integers. Here it is, unsorted. Let's call OddEvenSort on the var, and now it is sorted. This is how you work with source code in Kotlin and in Java. More or less realistic code real code, algorithmic code. Hopefully you can sense the utility of this the REPL environment that Meyvn provides. Again, Meyvn is free to use. The links are provided below for the website, for the installation instructions. You don't need to switch to Meyvn. You can continue to work with your favorite tools, Linigan, or whatever you are comfortable with. You can use Meyvn on top of it to experiment with the things I've shown here. And thank you for watching. Like and subscribe if you want, and see you next time. Thank you very much.